Right then, let's take a moment to appreciate what's about to happen every time you start your car. You're sitting in your car, about to set off, and you hear that glorious noise, the engine coming to life. It's a familiar sound, but have you ever wondered what's actually happening in those first few seconds? That's the sound of pure engineering genius, the internal combustion engine, turning explosions into motion. It's a marvel of science and design, a symphony of moving parts working in perfect harmony. Most of us just drive, never thinking about what's actually happening under the bonnet. We take it for granted, trusting that everything will just work. But today, let's lift the bonnet and see the magic for ourselves. We'll break it down step by step so you can see what's really going on. It's not just for mechanics, anyone can understand the basics. Whether you're a car enthusiast or just curious, there's something fascinating waiting for you. Imagine thousands of tiny controlled explosions happening every minute, all working together to push you down the road. Each one is perfectly timed, creating the power that moves your car forward. It's a symphony of fire and metal, and you're the conductor every time you press the accelerator. With a single touch, you unleash a chain reaction of energy and movement. We're not diving into complicated diagrams, just a simple tour of the engine bay. No need for a degree in engineering, just a bit of curiosity. By the end, you'll know what's happening when someone mentions pistons or cylinders. You'll be able to spot the key players and understand their roles. You might even gain a new respect for that lump of metal that gets you everywhere. It's more than just a machine, it's a masterpiece of human ingenuity. So grab a metaphorical spanner, let's dive in. We'll get our hands virtually dirty and uncover the secrets hidden beneath the bonnet. We'll explore the core components, the secret recipe of air and fuel, and the four-stroke dance that turns petrol into speed. You'll see how each part plays its role in this incredible process. Ready to peek behind the curtain? Let's get started. There's a whole world of wonder waiting just beneath that metal lid. Scene set, let's meet the engine's all-star team. Get ready to discover the unsung heroes that make every journey possible. Think of your engine as a factory, a place where raw materials are transformed into something powerful and useful. But instead of conveyor belts and assembly lines, this factory is filled with moving metal, controlled explosions, and a team of specialized parts working in perfect harmony. Just like any great factory, your engine relies on a few star workers to keep everything running smoothly and efficiently. First up is the cylinder, the main stage where all the action happens. This is where fuel and air come together, and the magic of combustion takes place. Most cars have 4, 6, or 8 of these cylinders depending on how much power and performance the vehicle is designed for. More cylinders usually mean more power, but also more complexity. Inside each cylinder is the piston, a tough chunk of metal moving up and down like a plunger. The piston is built to withstand intense heat and pressure, making it one of the hardest working parts in the engine. When the explosion happens, the piston gets shoved down with incredible force, turning the energy from burning fuel into motion. The piston connects to the crankshaft via a connecting rod, turning that up and down motion into a powerful spin that drives your car forward. The crankshaft is the clever rod that ultimately turns your wheels, converting all that energy into the rotation needed to move your vehicle down the road. Then there are the valves, precise gatekeepers at the top of each cylinder, controlling what goes in and what comes out. The intake valve lets in the air-fuel mix, opening at just the right moment to allow the perfect blend for combustion. The exhaust valve, on the other hand, opens to let out the burnt gases after the explosion, clearing the way for the next cycle. These valves open and close at exactly the right moments, thousands of times a minute, thanks to a carefully timed system of cams and springs. It's a perfectly timed ballet of mechanical precision, with every part moving in sync to keep the engine running smoothly. Each part has a vital role, working together to create power, efficiency, and reliability every time you turn the key. That's your engine's all-star team, each member essential, each one a specialist in its own right. Now let's see how they work together to bring your car to life every single time you hit the road. Time for the four-stroke cycle, the engine's signature dance, a perfectly choreographed sequence that transforms fuel and air into motion. It all begins with the intake stroke. As the piston glides downward, the intake valve opens wide, inviting a carefully measured blend of air and fuel into the cylinder. This mixture is the lifeblood of the engine, and its precision is crucial for smooth performance. Modern engines rely on advanced computers to monitor and adjust the air-fuel ratio in real time, adapting instantly to your driving style, the weather, and even the altitude. Once the cylinder is filled to perfection, the intake valve snaps shut, sealing the mixture inside and preparing for the next act. Now comes the compression stroke. The piston surges upward, squeezing the air-fuel blend into a much smaller space at the top of the cylinder. This compression dramatically increases both pressure and temperature, making the mixture highly volatile and perfectly primed for ignition. Imagine pumping up a bike tire. The more you compress the air, the more energy you store. The same principle applies here, but on a much more powerful scale. At this point, the air-fuel mixture is under immense pressure, balanced on the edge of a powerful transformation, just waiting for a spark to set things in motion. The piston reaches its highest point, top dead center, where the pressure is at its peak, and the engine is poised to unleash a burst of energy. All of this intricate action happens in just milliseconds, repeating thousands of times per minute as you drive down the road. The stage is set, the tension is high, and everything is ready for the explosive moment that powers your car forward. Let's see what happens next, as the engine prepares to turn all that potential into real driving force. Now comes the power stroke, the real action. The spark plug fires, igniting the compressed air-fuel mix in a tiny explosion. This blast forces the piston down, delivering the power that moves your car. The connecting rod and crankshaft turn this force into spinning motion. Each cylinder fires in sequence, creating a smooth, continuous flow of power. It's a relentless series of explosions, all spinning the crankshaft and ultimately, your wheels. Once the power is delivered, the piston reaches the bottom, and the burnt gases need to be cleared out. That's where the exhaust stroke comes in. Let's see how the engine cleans up after itself. After the power stroke, the piston pushes back up for the exhaust stroke. The exhaust valve opens and the piston forces out the burnt gases. The cylinder is cleared, ready for the next intake stroke. Intake, compression, power, exhaust, suck, squeeze, bang, blow. This cycle repeats thousands of times a minute. The crankshaft and camshaft, connected by a timing belt, keep everything in perfect sync. The car's computer, the ECU, controls the spark plug's timing for maximum efficiency. It's a blend of mechanical precision and electronic smarts. That's how your engine runs smoothly, mile after mile. Now let's see how different engines use this same principle. Whether it's a city car or a supercar, the same four-stroke principle applies. A small city car might have a 3-cylinder, 1-liter engine. Modest explosions for efficiency. Family cars step up with bigger engines and more cylinders, balancing power and economy. Supercars, they go all out. Massive V12s, huge explosions and mind-blowing speed. More cylinders and bigger bangs mean more power and a bigger grin. The difference is scale. How many bangs, how big, and how fast. But the core process never changes. Every engine, from the humblest hatchback to the wildest Ferrari, runs on the same dance. It's just a matter of how loud and fast the orchestra plays. That's the magic of the internal combustion engine. Now you know what's really going on under the bonnet. There you have it, the internal combustion engine, demystified. It's a simple, elegant solution. Air and fuel in, power out, waste cleared. Pistons, crankshaft, valves, and spark plug, all working in harmony. Next time you start your car, you'll know exactly what's happening. You're not just a driver, you're the conductor of a mechanical orchestra. Whether you drive a city car or dream of a supercar, you understand the heart within. You've unlocked the secrets under the bonnet. Power to you.